There we go. Okay. All right. So we'll start off today going over the homework. We'll see where that takes us. If we have enough time to kind of start the new lesson. If not, that's all right. Okay. So for homework, you had 4 law of sine problems and then 1 area problem. We were supposed to use our new equation for area. So we'll take a look at that first. So for the first one, we had a triangle with all 3 sides. And for the first part, I asked you to find angle C. And for the second part, I asked you to find angle B. All right, so luckily there is nothing else involved other than just doing the law of sines. So what we have is A, right? We know A, side A, and angle A. So that's what we're going to stick with for our proportions. So I'm going to use that to set it up. Again, it doesn't matter which one is on top, but because we're looking for the angles, I'm going to put the sine part in the numerator. Right? If you had it switched and the sine part was in the denominator and your side length was in the numerator, that is okay. So the first equation, the first part is the sine of 82 over 29. And that is going to equal, I'm looking for C. So the sine of C over, it always does that. I'm not trying to make a circle. The sine of C over 20. Again, I do it like this because to kind of start solving, all I got to do first is multiply both sides by 20. So I get 20 sine of 82 over 29 equals the sine of C. So I'm going to calculate the left side. All right, we can punch that in. 20 sine of 82 divided by 29. Now remember, we should get a decimal less than 1. And in this case, we do. We get about 0.68. I'll say 0.683. But remember, the more decimal points you use, the better. And then I'm going to take the inverse sine of that to get rid of that. Taking the inverse sine of our answer, I get angle C to be equal to you could say 43.1 or 43, but I'm going to say 43.07 just to be accurate. Now, angle B, you could have cheated and just done some basic algebra to find angle B. Right? If I subtract 82 and 43.07 from 180, I could find angle B. But I'm going to do it the long way. So again, I'm going to set up sine of 82 over 29, because that is what we know, equals the sine of B over, now I'm using across from B, I have 24. So to solve for B, I have 24 sine of 82 over 29. Oops, no, not inverse sine. 82 divided by 29. We get about 0.82. And then I take the inverse sine of that. I'll write out a couple of decimal points here. And I get about 55. And actually, if I'm being accurate, I do in fact get from the equation from this, I get 55.03. That would give me an extra decimal place. So maybe we won't round. Maybe we won't have the decimal points. All right, so if I don't include the decimal points, I just want to double check by adding up all my angles. 82 plus 43 plus 55 gets me 180. So we won't include the decimal points because that'll get us, excuse me, an extra 1/10 of a degree, and that wouldn't make sense. All right, so there's our answer for number 1 and number 2.
What if for angle C you got like 42.8?
Okay. Did you? So just if you get that, so you said 42.8. If you get that, then this would have to be, make sure that this would be 55.2, because when you add up all 3 angles, they have to equal that 180.
Yeah.
All right. So if you had 42.8 here and only 55 here without the 0.2, I might mark you off a point, because I mean, you got the right, you got the gist of it, but always double check when you're adding the 3 angles together.
Got it.
Right? Any other questions about the first 2? I'll let this go away. Excuse me.
Bless you.
Thank you. All right. Then for 3 and 4, I gave you a slightly different triangle. Only 2 of the angles and 1 side. And I asked you to find side J and then side L. All right, so J would be down here, and then side L would be over here. Now, for both of these, you would have had to use the law of sines. Okay. We don't have a right triangle, so there's no quick trick to find the sides other than using the law of sines. So for J, well, we know K, so I'm going to set that up. So now I'm going to flip it because I'm looking for the sides. So I have 50 over the sine of 84. And to find J, I'm going to put J up here over the sine of 42. All right, so we can calculate J by 50 times the sine of 42 divided by the sine of 84. And for that, we're going to get about 33 point. Okay, we'll be accurate here. 33.64. All right. Now for L, we need to do an extra step, but luckily it's not too terrible. We have to find angle L. I can't find side L without the angle. So for the angle, I'm going to subtract 42 and 84 from 180. And angle L here is going to be 54 degrees. All right, so you need that first. So again, I'm going to use K. I have 50 over the sine of 84 equals K over the sine, not K, L. Over the sine of 54. Cross multiplying. $50 sine of 54 divided by sine of 84. We're going to get L to be approximately 40.67. So we'll put that over here. Right. And again, there's really no way to check this, right? I can't add these up to equal something. So we just compare the opposite sides. 42 is my shortest side. I'm sorry, shortest angle. 33.64 is my shortest side. 84 is my largest angle. 50 is my largest side. And then L would be in the middle. So everything works out there. All right, any questions about that? All right, then for number 5 was an area problem. So I told you find the area of a triangle when angle B equals 39 degrees, side A equals 25 inches, and side C equals 12 inches. All right, so you could have drawn a picture to kind of maybe help you visualize what's happening. You didn't need to. You just had to pick the right equation. And I'll draw it out real quick. That's a little too isosceles, so this is not drawn to scale. No, not C. Meant to put 12 there, and C goes there. All right, so this is a rough sketch of what your triangle would look like. But again, it doesn't really matter because we have what we need here. All right, so given the information we're set up, the equation we're going to use is 1/2 AC times the sine of B. All right, so remember, just as long as we hit every variable, it could be any combination. It could have been 1/2 AB sine of C, or it could be 1/2 BC sine of A. They are all the same. They're all given kind of the same scenario. You have two sides in that included angle, right? It just matters where our points are located. All right, so our area is 1/2 of 25 times 12 times the sine of 39, and we can just plug that all in. 0.5 times 25 times 12 times the sine of 39. And our area is, I'll say 94.4 squared inches. Yeah. All right, any questions there? Oh, that's not our book. All right, so we got a little time. Let me just see if there's anything else with sines that we can talk about before we move on. That's a really long word problem. I'm not going to type that out. No, there's not. Okay, so there's not much else with the law of sines other than word problems. So we'll save that for now. All right, so with the rest of this, I do want to introduce you to what we'll be doing next week. It'll be a combination of things. But let me see where, let me keep. So we do have the law of sines. And we also have the law of cosines. So there are, law of sines only covers two specific cases of triangles. We saw angle side and side angle. So we need another rule, another law to help us solve other types of triangles. Now this one is interesting because this is the first time that we are able to solve for an angle when we don't have any other angles. Okay, so when we're given side, 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 all three sides, and we don't know any of the angles on the inside, we can use the law of cosines to solve for that. Now, there are different forms. There's two different forms. There's standard form and then the alternate form, and that's what we'll talk about today. We'll just get through those. Now, there's three types of each standard and alternate form. And then, like the area with law of sines, it just depends on what information you're given and what you're looking for. So for standard form, we're looking for the sides. Now, we're also using a little bit of the Pythagorean theorem. So we're kind of taking into account that we have a triangle, so we can set up right triangles inside our triangle, but we may not have that right angle. All right, so if I have some triangle where I don't have a right angle, okay, so if I'm looking for one of the sides, so this would be for a side angle side, right? If I had side angle side, I wouldn't have enough information for the law of sines. So I use part of my Pythagorean theorem. So I have a squared is b squared plus c squared. But because we don't have a right triangle, I have to manipulate the equation to balance it out. So we subtract 2bc times the cosine of a. All right, so it looks like a lot, but it's really, if I'm looking for a squared, then I'm just plugging in numbers over here and solving and then taking the square root at the end. Right, now these alternate forms are just, well, not alternate forms, these other forms are just different ways of writing this. So you're going to kind of notice a pattern like we did with the area. So b squared, we're going to say is a squared plus c squared minus 2ac times the cosine of b. And then c squared is going to be a squared plus b squared minus 2ab cosine of c. All right. So it may not be clear right away, but there is this kind of pattern where if I'm looking for a, then I'm using sides b and c and angle a. If I'm looking for b, I'm using my other sides a and c and angle b. And then for c, same thing. I'm using my other sides a and b, and angle c. Right? So that would be this side angle side part. So we do have an alternative form, which we use when we are trying to solve side, side, side. So this is specifically when we don't have any of the angles. Right? If I'm given all these three sides and I'm looking for an angle. So essentially, all I'm doing is I'm solving each one of these equations for the cosine part. So I'm going to have cosine of A is equal to b squared plus c squared minus a squared all over 2bc. Okay, and I want you to notice this. There's also a pattern with these as we go along. Cosine of b is going to be a squared plus c squared minus b squared over 2ac. And then cosine of c is equal to a squared plus b squared minus c squared over 2ab. All right, so if we're looking for an angle, depending on what angle we're looking on, we're going to be subtracting the square of the opposite side. And then all the other numbers here are going to be your other two sides, B and C. All right, so let me see. I think I just learned this. Nope, wrong thing. Nope, wrong thing. I guess I can't. Thought I could zoom out. It's not letting me. Okay, anyway, there we go. All right, so next week we will start using these law of cosines. We'll do some problems, some basic solving problems, and then applications on how we can use these otherwise. Now, you may be, what's nice about the law of cosines, though, is we only have to use it once. Once we use the law of cosines to find that missing part, then the rest of the triangle will either be normal triangle stuff or law of sines. All right, so what's nice about this is, it's a little lengthy, but if they ask you to solve a triangle and you need to use this, you're only going to use this one time. You don't have to use this twice. I mean, you could use it more, but I think personally law of sines is a little easier. You just have to set up your proportion instead of everything going on here. All right, so we will cover that next week. And we're getting close to the end of trigonometry. Almost done. There might be a lesson that we're not supposed to learn, but I want to teach you anyway because it's real cool. And yeah, we'll see where that takes us. All right, guys. That's it for us today. Have a great weekend, and I'll see everybody on Monday.